Good morning, everyone. Today's lesson is about one-sided limits. And when we say one-sided limit, it refers to the behavior of a function as the input approaches a particular value from one side. So that means we're talking about from the left side or from the right side instead of approaching from both sides. So there are two types of one-sided limits. The first hand is what we call left hand limit, and that is this is the mathematical definition of that. And then we also have the right hand limit, and this is the mathematical definition of that. Okay, so let me give you some illustrations here. I have four. I'll give you two about graphs and then two about table of values. So let's consider this graph, and the question is, what is the limit of this function as x approaches negative 2? So that's the first question here. All right, that's question letter A. So as x approaches negative 2, boom, there you go. It's going to be this point, so that means it's positive 2. And but what if as x approaches negative 2 from the right side? So that means this side, and it's going to be approaching the same point, positive 2. All right. But it's not always be the case like that. And I'm going to give you an example wherein the limit as x approaches to the left and to the right side are going to be different. But before I go there, let me give you another example, this time table values. So here we need to find the limit of f of x as x approaches 1 from the left and from the right side. So here, all you need to do is just to focus on the y values. So here, and then on this side, right? So the last number here in the middle is 3.002. And as you can see, the numbers are decreasing 3.36, 3.19, 3.02 to 3.002, and it looks like it's approaching number 3. And then from the right side, if you look at this, so 2.78, 2.98, this is increasing, and it's consistently increasing. If x equals 1.0001, the equivalent value is 2.999 with respect to f of x. I think that's also getting closer and closer to 3. Hold on, what is happening? There you go. So as x approaches negative or positive 1 from the left, that's 3. And as x approaches 1 from the right side of this f of x, that's also 3. Similar to illustration number 1, the left-sided left-hand limit and the right-hand limit are the same. Now let's consider illustration number 3. Okay, so here we need to find the limit of f of x as x approaches negative 1. So that means we're talking about the blue graph. That's the focus. All right, and it is approaching this point, and that is positive 2. All right, and then here, the limit of f of x as x approaches 1. That means this side. Oh, that's not curve. I want it to be curvy. There you go. It's not going to bind. It's not going to be defined when x equals 1, but it is approaching negative 1. Right. So this is negative 1. And here in illustration number 3, as you can see, the left hand limit and the right hand limit are different. All right, let's go to the illustration number 4. This is the last illustration, and then after this, I'll give you some problems about left one-sided limits. Okay, so what is the limit of f of x as x approaches positive 2 from the left? Let's focus on that first. And here this is 2.24 if x is 1.8. And as you can see, the numbers here are increasing, and I think it's getting closer and closer and closer to number 3. So this is 3. And then as x approaches 2 from the right side of that f of x. We have negative 1.9, negative 1.99 until negative 1.9999 when x is 2.0001. And I think this is getting closer and closer to integer negative 2. And as you can see, the limits are different. Okay, now we have to take note of our observation here. So what are the two observations? So one possibility is that the limits from left and from the right can be equal, like illustration 1 and illustration 2. And then there's a possibility wherein the limits from left and from the right side are going to be different. So what are going to conclude if that is going to be the case? So we have to take note of this. So for the overall limit of f of x, so here we're talking about the overall limit as x approaches a to exist. Both one-sided limits must exist and must be equal. So meaning the limit of f of x as x approaches a will be equal to L if and only if the left hand limit and the right hand limit are going to be equal. Okay? So now let me give you some examples. All right, so here we need to answer these 5 questions. First, what is our limit of f of x as x approaches negative 2 from the left? So I think we're talking about this one. It's not going to be defined at this point at negative 2, but this is negative 2. I'm talking about this negative 2 here, the y value. So this is negative 2. And then from the right side, we're talking about this graph here, and this is approaching 1. All right. Now, what about the limit of f of x as x approaches 2 from the left? So we're talking about this one. That's positive 1. And then finally, oh no, second to the last problem, for a limit of f of x as x approaches 2 from the right. So we're talking about this, and that is negative 1. Now, question, what is going to be the limit of f of x as x approaches 2? So as you can see, there's no notation on top like it's going to be positive or negative. It's just 2. So for this limit to exist, what are the conditions? Or what's the condition rather? The left hand limit and the right hand limit must be equal. So that means we need to look at 3 and 4. Are they equal? No. So that means the limit does not exist, okay, of x of this function as x approaches 2. So it does not exist. All right, let me give you this example again. So what is the limit of f of x as x approaches negative 1 from the left? So this, I think that's positive 1. Limit of f of x as x approaches negative 1 from the right side. So that means this, that's negative 1. So we can conclude here, it's not a problem, but let's say we want to find the limit of f of x as x approaches negative 1. It's not going to be exist because the left hand limit of the function as x approaches negative 1 from left to right are not going to be equal. So for number 8, we need to find the limit of f of x as x approaches 3 from the left here. That's negative 2. And then limit of f of x as x approaches 3 from the right. That is positive. That's negative 2. All right. Now what is the limit of f of x as x approaches 3? Now since if you look at number 8 and 9, the left hand and the right hand limits are the equal, which means that it's going to be defined and the limit of that f of x as x approaches 3 is negative 2. Okay. Now, one-sided limits when it comes to graph is going to be, I think, a little bit easy, but and also when it comes to maybe algebraic um, functions. But the only I think concern that you're going to have is, what if the function is a piecewise function? How are we going to solve the one-sided limits if it's a piecewise function? So I have here four examples, I believe. Okay, there's only one problem here. We need to find the limit of f of x as x approaches negative 1. Now, to answer this problem, all we need to do is to look at the inequality symbols. So we have here less than and less than or equal to. So that means we will use the less than or equal to 4. Now, maybe you're thinking, well, that's not part of that domain. Well, it doesn't really matter. Okay, it's not going to be defined on this graph, but that value of 4 is going to be approaching to the left using this uh, formula x plus 1. Okay, so we will use this only. So which means that the limit is going to be 4 plus 1, which is equal to 5. Okay, so meaning the inequality symbol, uh, like the less than and less greater than or equal to, you're not going to focus on which uh, inequalities is problem is the number 4 is going to be included. Okay, no, you got to look at the less than and the greater than only. It doesn't really matter if it's less than or equal to or greater than or equal to. Okay, so here we need to find the limit of f of x as x approaches 3 from the right side, so meaning we need to look at that greater than symbol. So if it's less than, look at the, I mean, uh, uh, the negative, meaning less than, and then if it's positive, you need to look at the greater than. Okay, so this is 3 minus 1 square minus 2, which is 2 square minus 2. It's 4 minus 2, which is equal to positive 2. Okay, now for the past two problems, including this one, the limit is specific. We want to know the left hand, and this one is the right hand. But if the question is, let's say this one, what is the limit of f of x as x approaches 2? This is not like a one-sided limit problem, but we need to find the left hand limit and the right hand limit to find if the limit of f of x as x approaches 2 exist. We want to know those two. So first, let's use the x squared minus 4, the left hand limit. So that's 2 square minus 4, which is equal to 0. So the left hand limit is 0. What about the right hand limit? So this is 2 plus 1, which is equal to 3. That's the right hand limit. Now, since 0 is not equal to 3, the limit of f of x as x approaches 2 does not exist. Okay, I think that's clear. Now let's check the last example. Again, if you want to know, the question here is not really a one-sided limit as f of x approaches negative 1 from the left or from the right side. Negative 1, we need to find the limit of f of x as x approaches negative 1. But even if that's the question, we need to find both the left hand limit and the right hand limit. So let's find the left hand limit. That's negative 1 raised to 3 plus 5, which is negative 1 plus 5. And that's 4. That's the left hand limit. The right hand limit is 2 times negative 1 plus 6. This is negative 2 plus 6, which is equal to 4. So that's the right hand limit. Now, since the left hand limit and the right hand limit are equal, and that's equal to 4, that means that the limit of f of x as x approaches negative 1 is also 4. All right, I hope that is clear, and I hope you learned something from this video about the lesson one-sided limits. So again, thank you for watching. You have a good one. Bye.